This here is pitch data, and it is the complete death blow to the globe. My friends from Quantum Erasers channel go over this pitch data and demonstrate that it's completely impossible for this pitch data to support a globe model. It could only work on a flat earth model, and it's game over to all the global pilots and to globe earth entirely. Now, it is a bit of a lengthy video, but stay tuned and watch the whole thing because they go over exactly how a plane flies, how it doesn't work on a globe, and how the pitch data completely destroys the notion that the Earth is a globe.
Right, if we were talking about a globe, that would be a straight line which would place the plane at 132 miles, right, above that 1,000 mile point on the globe, right, our plane, right. And if you take away the 6 miles of altitude, it's 126 miles. So technically, according to the pitch data and the actual data of the actual flight, the plane was 126 miles out of whack with the globe. Planes couldn't exist if the Earth was a globe. Planes, air travel and planes can only exist because the Earth is a flat plane. That allows people to go from A to B in straight lines because that's the only way a plane can fly. It cannot fly around a curved surface because that would mean losing lift. This is, you've seen it out there, we've all seen this. This is the attitude indicator. Where those two orange lines are across that black line with that orange dot in the middle, that's 0 degrees. That's the horizontal that's been created, right, by the gyroscope. The purple line I have placed in here, right, this purple line would represent kind of an average above horizontal pitch throughout a flight. So anything below where those two orange lines are would be a below horizontal pitch, right? Now, those orange lines would be up where that pink line is or purple line is, because that's what would raise it lower. And the black line would be the 0 degrees. But anything below, let's just say those two orange lines, if that purple line went below them, that would be a below horizontal pitch. During flight, the pilot will always have an average of this much pitch above that black line, where that purple line is. It might be slightly, if you want to go faster, it'll be slightly closer to the black line. If you want to go slower, it'll be slightly further from the black line. But the point is, it'll always from Vancouver to Miami, or from your house to your friend's house 100 miles away, it's always going to be above horizontal. It will always be above that black line because they can't pitch below it, right, without using lift. This blue line along the center of let's say along the middle, it's slightly below the middle, but the blue line along the middle, that is your 0 degree. You have a line coming up, right? We'll call another line moving through the wing here called the chord line. Another blue line at the wing above it called the chord line. And the same on the diagram at the bottom. You have another blue line, unbroken line, and that's called the chord line again, right? So you have the same wing. In one part of the diagram, it's pitched above horizontal. In the other part of the diagram, it's pitched below, right? Now, you have another line, a broken line on the above part of the diagram, a broken serrated line with 0 lift line wrote on it, right? And you have the same, on the bottom, you have the same serrated line, but it's not at an angle, with 0 lift line written on it there as well. That 0 lift line, right, above, on the part above, that is when the plane or the pilot pitches too far above horizontal. What happens is they'll reach a point where the plane will stop generating lift. They'll reach a point called stall. And when they reach that point, but it basically means they can't operate the plane correctly. And the plane can then just start falling out of the sky, because they're not generating lift because they are too much above horizontal pitch. So here we have a globe Earth, right? And we have a red serrated line around the outside of it, depicting an altitude above it. So if you want to hold a constant altitude above that globe Earth, you've got to follow this red serrated line. So for this plane that starts at this black dot here, up above where it says altitude above a globe, right? For that plane and that pilot to travel around the globe, let's just say this blue line, the length of this blue line as an arc is about, let's say one quarter, right, or 1/5 of the full arc of the full circumference of the globe. For that plane to do that, then bit by bit, right, that pilot from the minute that they get to cruising altitude, they can only be horizontal technically from a mathematical point of view for 1 second. After that, they're going to have an accumulated below horizontal pitch to follow this red line around the outside of the globe. That's what it has to be, because remember that red line would be mean sea level on the globe, right? A parallel, or would be emulating mean sea level 6 miles above, 5-6 miles above, whatever, right? So the only way for them to do that is to have an accumulation of below horizontal pitch. And as you can see by the blue line, right, as the further they travel in a straight line, the greater the amount of below horizontal pitch they would have to have. But they can't pitch below horizontal because they won't have any lift. So they must follow this straight blue line. There is no way around it. Now, how can they follow this straight blue line, hold a constant altitude at the same time, right, not crash into anything, and get from A to B safely 10,000 times a day if the Earth is a globe? Because if the Earth is a globe, they'd have to follow this red line and have no lift and eventually crash into. There's just been no way around it. It's not there's literally impossible. The lift effect makes it impossible for a plane to fly around a convex surface, a consistently convex surface. It's impossible. They can't do it because they have to break this blue line, this blue horizontal line, to follow this red serrated line, and they can't do that because they won't have lift. If you don't have lift, it's like not having wheels on your car. You're not driving anywhere.
For Globetardia, just to give a little background, a little context. Location, Honolulu, Hawaii. Date, February 13th, 2018. Aircraft, Boeing 777. Operator, United Airlines. The text reads, on February 13th, 2018, about 1200 hours Hawaiian Standard Time, HST, a Boeing 777-222 airplane operated by United Airlines as Flight 1175 experienced an in-flight separation of a fan blade as well as the inlet duct and fan cowls of number 2 right engine, a Pratt & Whitney, during cruise flight en route to Daniel K. Inouye International Airport, Honolulu, Hawaii. While the airplane was in level cruise flight at flight level 360, that's 36,000 feet, the flight crew heard a loud bang that was followed by a violent shaking of the airplane that was followed by warnings of a compressor stall. The flight crew shut down the engine, declared an emergency, and proceeded to HNL, Honolulu International Airport, for a single engine landing without further incident. Landing at about 12:37 HST. The 364 passengers, 2 pilots, and 8 flight attendants on board deplaned normally at the gate, and there were no injuries. The airplane was operating as a regularly scheduled flight in accordance with the provisions of 14 Code of Federal Regulations CFR Part 121 from the San Francisco International Airport, SFO, San Francisco, California, to HNL. One more small thing that Brian will be going over that's encased in this document and is the death knell for Globetardia. He will be showing this. And ironically, dovetails with my B example on the globeterminator.com. On the x-axis, right here, it has 800 hours. I will move to 1,000 hours. That is 2-hour flight at an average of 500 miles an hour, sunshines. I just wanted to point this out. Brian will be going into this in his presentation momentarily.
There won't be any pitch down without the altitude of the plane changing, which means that they had to change altitude, and so they had to pitch down for that moment. But after that, they pitch back up, and it's back to holding an above horizontal pitch. The orange line being the pitch, and I put in a blue line here at 0 degrees. As you can see very clearly, at no point does that orange line ever dip below the blue line. Only at 2 points does it appear to kind of slightly do it. And at both those points, and the first point is more pronounced, there's a change in altitude, which means that you can see from the black line of the altitude here, the plane literally descended, which means at the depression angle downward, right? Then leveled out again, then descended slightly again, right? Then leveled out again. And every time they level out, the pitch is back up above the blue line, which is above 0 degrees, which is above horizontal, because it has to be because of lift, right? And as you can see, then they have an increase in altitude, right? And you can see it's matching the pitch, and then they level out again, and then they land. And that, when you see that wiggly line at the end, that's what landing always looks like, because there's a lot of pitching and moving around and up and down going on for the landing, right? So that's basically, from what I can see, what landing always looks like on the pitch data, right? But it is totally obvious, without a shadow of a doubt, that at no point is there any point that there isn't a consistent above horizontal here. And this is from once the plane got into the air, you're talking close to 8 o'clock in the morning, right through to, you're talking 12:30 in the day, right? So that's many hours of it being above. Okay, this is the same as the last line I just added in sepia for the audience. They might be able to see it a bit clearer. And some people, with the colours, they might have an issue, like Nathan is colourblind, so this might help them see it better. Where the black line, where you see pitch, and the black line underneath where it says the word pitch, that is, right, 0 degrees. And the pitch is above that at all times, right? So there was no way around it. This is the actual data, right? The black line is the consistent horizontal that could never be broken. That could never be broken and was never broken during this flight and isn't broken during any flight. If you're talking about any flight that's going from a distance from A to B. I'm not talking about acrobatics in a jet fighter. I'm talking about going from A to B. At no point is that black line broken. They must always pitch above that black line, which means they're never pitching below that black line, which means they're never breaking that black line, which means they're traveling along that black line, essentially. The section we're going to focus on, right? This is from 8:05 in the morning to 10:05 in the morning. So this is 2 hours where there was no need to change in altitude. As you can see, the altitude, pressure, right, remains equal, which was, I think it was around 35,000 feet, and the pitch remains equal above horizontal. There's no need to change an attitude. There was no pitching down or pitching up. It was consistent for 2 hours non-stop. Now that means that the plane flew right at 500 miles, because we worked it out with the airspeed. It flew at 5,000 miles an hour, right? That's statual miles, right? For 2 hours, that's 1,000 miles. So there was 1,000 miles of flight happened, where at no point did they have to change an attitude, so at no point did they have to change their pitch. So they held probably a constant, I think it was around plus 3 degrees above horizontal pitch, constantly for 2 hours. Okay, this next slide, I've drawn up on GeoGebra, right? So this is from point A to point B, right? So for that 2 hour window, right, that was 1,000 miles traveled. Now, if they could never break this blue serrated line at any point, right, that means the plane flew this track. It flew this straight blue serrated line from point A to point B, which means that technically, right, if you were talking about trying to add in a globe, it was 132 miles, right, if we were talking about a globe, that would be a straight line which would place the plane at 132 miles, right, above that 1,000 mile point on the globe, right, airplane, right? And if you take away the 6 miles of altitude, it's 126 miles. So technically, according to the pitch data and the actual data of the actual flight, the plane was 126 miles out of whack with the globe. That's what it shows. But more importantly, it shows that there is no globe, because there can't be. Because planes can't fly the way they must fly, and the Earth be a globe. It's just impossible.